Hello, teacher. We are group 7. Today we're gonna introduce to you of our final project of optimal engineering. Our group has three members: Nguyễn Thành Huy, Nguyễn Duy Long, và Nguyễn Văn Phong. Uh, Here is the uh, real problem of us. Nguyễn Thành Huy will introduce.
The real number of my team is two identical spring yield as motorcycle force weighing uh, 2,500 pound. The problem is to find the diameter of the steel wheel, the diameter of the coil of the spring, the number of spring of each spring so that the mass is the smallest. P is density of spring material. G is shear modulus of spring material. Ks is shear steel shear stress correction factor. F is load acting on each spring. G gravity acceleration. This is a picture about the fork in the spring. Uh, the first one is variable. X1 is still with dimension. The diameter. Uh, the unit is in X2 is spring coil diameter. Uh, the unit is inch. H3 is real number of each spring. The unit is Newton. H4 is spring deformation length. The unit is inch. H5 spring length after being restored. The unit is inch. And to continue, Yilong will presentation.
Next, my group will introduce about the objective function. As we mentioned above, we have five variables, and the following is the formula to have this function achieve the minimum value at min. The formula equal to 0.3 multiply b square divide 4 multiply x1 square x2 x3 x4 and x5. As you can see at the below, we find some formula that make it possible to easily find the objective function with the minimum value. Next. We come to the constraint function. The first is the spring deformation function. It has a limit from 0 to 0.1. Next is forward stretch from 0 to 1e for BSI. The oscillation frequency from 0 to 100 Hz. The ring elasticity coefficient from 0 to 0.04. And finally, the recovery force from 0 to 1,250 bar. The next part is form presentation.
From the objective and the constant, we combine together, and then we have these five functions about spring deformation, forward stress, oscillation frequency, spring elasticity coefficient, and recovery force. About all these functions, we import it into the MATLAB with the function that here the first picture, the function sequence, the second picture, and in command window we import the x0 which is inside the constant. The L we import lower bound and upper bound also, and then after MATLAB calculate, we got the result that is 0.001, 0.0825, 49.9065, 0 and 600 and 0082. About the G, we have a 2.8 55A. And then we convert it into the millimeter and Newton and kilogram unit. Here we have the result. X1, X2, X3, X4, X5, and Z. Thank you for listening. That's all about our final project.